Hello again, welcome back. We are in week 6. This is video number 6, and we're going to be talking about volume. Okay, now we're going to talk about volume. Okay, let's go over to our star reference sheet. Okay, and the volumes that we have two different volumes outlined. All right, we have prisms and pyramids. You will see later that we have different types of prisms and different types of pyramids. All right, and so if you'll take a look at this, remember, okay, capital B is area of the base. That's area of the base. That's capital B. You remember up above, little b, okay, lowercase b, those are all the length of the base. Capital B or big B is the area of the base. H is still that's the height of the, in this case it's a prism, okay, height of the prism. Okay, this is where the two H's get a little bit confusing. All right, so let's go on over and start taking a look at this. Okay, so when you look at the volume we're going to start with rectangular prisms. The volume is total capacity, okay, the capacity of a three-dimensional object. That describes how much space the object occupies. And we're going to look at each one of these and see that what the bases are. And so you could take a look, and so here's the base of this three-dimensional object, and you can come over here and take a look at this one. Now, for this one, all right, typically your rectangular prism, okay, you will have the base, which is what you're sitting on, but it's not always, or what it's lying on. It's not always the case, but in this case it is. And then here, your third rectangular prism, there's your base. Now remember, there are more than just one base, isn't there? Okay, good. I want to make sure. I want to see who's paying attention. So you have two bases, okay, on each figure. Okay, each rectangular prism. All right, and then two on that one. Okay. All right. So here's what we need to make sure we understand about a rectangular prism, or about the bases of those prisms. Okay, the base of an object is what names that shape. The base of that object is what names it. So if you have a rectangular base, then it has a rectangular prism. Okay, remember, prisms have two bases and they are parallel. Okay, and that means that they do not touch. Okay, these bases do not touch at all. All right, rectangular prisms, you can the volume can be determined by first finding the area of the base. Okay, remember, area of the base, which is big B, and you multiply that by the height of that object. Okay, and so that means our volume is big BH. We looked at that already. Okay, all right, let's go on down and solve this problem. Now, it's very difficult to draw a three-dimensional object on a sheet of paper, on a two-dimensional plane. All right, and so what I like to do is, it's a little tricky to get used to it. Okay, I like to kind of draw it in. And let's see, I think, did I get it? Okay, that's pretty good. All right, there we go. That's a lot better. To me, that's a lot easier to see. Okay, and so now if you've got this, now you've got this outlined. So there's my base is on the bottom. That's my base 1. Okay, and then you've got base 2, which is on the top, right? Okay, everybody see that? How you got two bases on this rectangular prism? Okay, so the orange base is 6 by 9. Okay, so this would be the area of the base. Okay, area of base. Okay, and that's little b times h, which is 9 times 6. Okay, that's 54. All right, so that 54, okay. All right, let's come over here and look at that. So then we've got volume is equal to capital BH, where capital B, or big B, is the area of the base. That's 54. We just determined that on the bottom left. So now let's plug in those values. So V is equal to 54. Now the height of this overall between the bases. This is what's very important. The height of the object is the distance, okay? The height is distance between the bases. Distance between the bases for the prisms. Okay, a little bit different when you get to other objects, other shapes, but right now we're looking at prisms. Okay, so now we've got that distance, that's 4.5, so we've got a 4.5. So now I'm not going to work through all this, all the math for you, but I will tell you that's 243. Now this is what's very important. Volume units, okay, we have centimeters. Volume units are cubed. We multiplied 3 times, or had 3 numbers we multiplied, so we have cubed. Okay, that's our volume. Okay, volume is always a cubic unit, whatever that unit might be. In this case, centimeters. Okay, that's a rectangular. Okay, that is a rectangular prism. Okay, all right. So I'm going to let you take a screenshot of that real quick. Okay, all right. Let's go and see what's next. We did a bunch of these example problems. All right, so we're going to take a look at a triangular prism. Okay, now a triangular prism, okay, we're using the same formula, okay, because it is a prism. So V is equal to big BH, okay, but in this case, the base is a triangle because it's called a triangular prism. So that big B, or capital B, is actually equal to the base of a triangle, okay? So that height of the prism is the distance, we mentioned that a moment ago, between the bases. Okay, so the area of a triangle is on our star reference sheet. So the area of a triangle is 1/2 base times height. That's the area of a triangle. So when we're looking for these problems, solving these problems, okay, we have volume. Oh, excuse me, I've jumped ahead of myself. So we're going to practice finding the area. So the area is 1/2 base times height. Remember, the height always creates a right angle. So this is not, and this is not. Okay? So then we have, plug in the values. Area is 1/2 of 14 times 7. Okay, so then you have the area is 1/2 of 98. Therefore, my area is equal to 49 square feet. That's the area. So when you find the area of this triangle, okay, that is the first step to finding the volume. I know it gets a little tricky, but remember, we've got these notes and we've already talked about them before. Okay, so that's finding that area. So now we're going to come down here and then we're going to shade the base. Remember, it's the bases are named, okay, the object's named because of the base. And so if you'll take a look, this is a triangle, so there's one base. Okay, and here's our second base. There are our bases. What's the distance? How far are those bases apart? Okay, you can go from here all the way down to this next one. That is the final, that's the H that we're looking for at the very end. That's our H value. Okay. Similarly, here are our bases, okay, for the this next one. All right, there's the bases for those two shapes. Okay, let's go to our example on the bottom. Find the volume of this triangular prism. It's a triangular prism. So the base, big B, is going to be the area of this triangle. So big B is the area of the base. Okay. So big B is area of the base. So that's going to be equal to 1/2 BH. Because, all right, so remember the base of the triangle is here, but the height creates a right triangle. This is not. Okay, so then we have that big B is 1/2 of 4 times 3.5. So that would be equal to 1/2 of 14. So then big B is equal to 7. I know I went through that very quickly. If you need to take a snapshot and then go back through that, you can ask questions later. That's fine. Have no problem. Shoot me an email. We can ask that. Okay. Now, one thing that that they did not do as well is they did not. Okay, that they did not draw. So our other base is here. Okay, what is the distance? Okay, what's the distance between these two pink bases? What's that distance? Because that's the height of the prism. Okay, the height is 7. Okay, so now we're going to come over here and find that our volume is equal to big BH. Plug in those values. Okay, on the left side we see that big B is 7. The H here is also 7. So we see that our volume is 49 cubic feet. Okay, very, very quick. Take a snapshot. Okay. All right, so let's see. We've got triangular prisms. We've already looked at those. Now we're going to take a look at the volume of a rectangular pyramid. The volume of a rectangular pyramid. The pyramid all comes to a point, but the base is a rectangle. Remember, it's named for what the bases are. Okay, so when you're going to take a rectangular pyramid, has a rectangular base, so big B is little bh, okay? Then the height of the pyramid can be measured from the vertex. The vertex is that point on the top, okay? Straight through the pyramid to the base of that pyramid. It does not follow the length of each triangular face. So our formula is 1/3 big BH. Okay, so the first thing we're going to do is we're going to find the area. Okay, find the area of the base. If my base is here, okay, so the first thing I'm going to do is find big B. That's the area of the base. So in this case, it's a rectangle. So little BH. Okay, so little BH is 8 times 3.5. Okay, so that big B would be 28. So step 2, what's the height of the pyramid? Okay, H should be equal to 13. Okay, that's the height because it goes down and creates a right angle on the base. So finally we have, okay, so, and I went ahead and solved all this over on the other side. So the base is 28 square centimeters, but the volume is 1/3 big BH. So that's 1/3 of 28 times 13. So the volume is going to be 1/3 of 364. Remember, 1/3 of something you divide by 3. So 364 divided by 3, okay, that volume would give me 121.3 cubic centimeters. Yes, it's a lot of work to find the volume of a rectangular pyramid. Okay, take a snapshot of this example problem. Okay, one more. I think we've only got one more example problem. There's a rectangular pyramid. Go ahead and take a snapshot of that if you need to. Okay. All right, triangular pyramids. Triangular pyramids. All right, so when you look at a triangular pyramid, okay, it has a, I know it's crazy, but it's a triangular base. So if the base is a triangle, that means big B is 1/2 base times height. So be careful. Don't confuse the height of the triangle base with the height of the pyramid. Be very careful. The formula for volume, again, is 1/3 big BH. Okay, 1/3 big BH. Okay, now let's see what we can. Let's see if we can solve us a problem here real quick. Okay, so if you'll look at this pyramid, be very careful. So these are very hard to see, and this is why I know it's difficult. Okay, so here's our base. This is a pyramid base. All right, this is the base. It's a triangular pyramid. So big B, okay, is the area of the base. So that's 1/2 BH. So if this is the B for the base, that's the H. Okay, so that means big B is 1/2 of 3 times 4. This is just the area of the base. So big B is 1/2 of 12. Big B is equal to 6. Okay, so that's big B. That's 6. But the volume is 1/3 of big B times H. Finally, the H, the height of the pyramid, reaches down to the base. So that's the height of the pyramid. Okay, so then we've got big B, so we've got 1/3. Actually, let's do it this way. Make it a little smaller so we can see it. So that's 1/3 big B times H, which is 1/3 of 6 times 7. All right, so that would give me 1/3 of 42. All right, and so 1/3 of 42, that should be 14. So we've got the volume is 14 cubic centimeters. Okay? There is the volume of a triangular pyramid. Take a quick snapshot. Okay, that's all of our examples. That's all of our volume problems. Okay, that finishes up video number 6 for this week, and we have one more, and we'll be done for the week.